The lab problem this week was to measure the force between two magnets as a function of the separation of their center of mass. We had to plot this to find a mathematical relationship between force and separation of the magnets. Because of their magnetic fields, two magnets can either attract or repel each other. Since the magnets we used were very strong, we decided to measure their repelling force, since it would be easier to record how much force is needed to push them together than to determine how quickly they were accelerating together. We therefore had to line the magnets up so that their like poles were pointing towards each other. To set up, we attached a clear plastic tube to a clamp on a retort stand on a table. We stood a ruler next to the plastic tube and inserted the magnets into the plastic tube so that the same pole was facing each other. We also collected around 50 small lead balls, of which we weighed 10 to determine an average mass of 8.39 grams per ball. The mass of the magnet used was 17 grams. We determined that the repelling force between the two magnets was equal to the force of gravity on the top magnet. This force could be found using F equals mg. Initially, this force was equal to the mass of the magnet multiplied by 9.8 meters per second squared. We then began adding lead balls one at a time to the tube. With each addition, downwards force, and therefore repelling force, between the magnets increased by the lead ball mass multiplied by 9.8 meters per second squared. The distance between the top of magnet 1 and the top of magnet 2 was recorded with each addition. We continued this process until no more balls could fit in the tube. I inputted our data into Excel and created a graph demonstrating the relationship between force and separation of the center of mass of the magnets. To get an insight into this relationship, I calculated the log of force and also plotted this with distance, receiving a graph with a linear trend of the form y equals b minus nx. From this result, I determined that force must take the form F equals c over r to the power of n, where r is distance between the magnets and c and n are constants. To find these constants, I added a power trend line to my graph displaying the relationship between force and distance. This trend line has an equation of F equals 6.19 times 10 to the negative 7 multiplied by r to the power of negative 4.61, which fits the form I determined previously. I therefore determined the mathematical relationship between force and separation of our magnets to be F equals 6.19 times 10 to the negative 7 over r to the power of 4.61. This trend line has an r-squared value of 0.996, which is a relatively high value and means that the equation fits the data well, indicating that there was little error in our final result. Thank you for watching.